Hey, everybody. Thanks so much for coming to the talk, even though it's the end of the second day. I know everyone's probably pretty weary of listening to us all talk, but I will try to be entertaining and get you to kind of understand how JWTs work and what you can use them for and how to use them. So this is mostly about authentication. A good example is OAuth 2 doesn't require JWTs, but they're very common. So it's a method of passing information back and forth between your servers and your clients that allows you to have an actual stateless situation and avoid all of that Kubernetes sticky session fun that everyone has to do. So, so today I'm going to unpack JSON Web Tokens, JWTs. They are pronounced JWT. They took the time to put that in the spec, so we can all appreciate that, so that we don't have to say JWT every time. Save a lot of syllables. It's all good. Let's take a look at what we're going to cover today. First, we're going to start with an overview of JWTs, like what are they, why do they exist, what problems are they solving. So I'm going to get you to understand sort of how the stateless authentication works and why it's helpful for you. Next, we're going to dive into the details of JWTs. So we'll talk about the structure of a token, how it's put together, and walk through how it's created, how it's validated and used in real-world situations like microservices and APIs. Finally, we're going to finish up with JWT best practices. Because it is a token, it's very tempting to put it in your local storage in your browser. Hopefully, by the end of this talk, we will all agree that that is not what you should be doing. We have HTTP-only storage, which is secure, and we also have, you can also store things in memory, but please, not in local storage. So when we talk about JWTs in the context of DevOps, as we're at DevOpsDays, we're really talking about enabling modern and scalable and secure systems. They're perfect for stateless authentication. This is what we need for cloud-native apps. This is where people end up with those sticky sessions and the coordinators on the back end to make sure everybody's still in the same place. But this means there's no need for those or the centralized stores, which simplifies the whole operations side of your application. Because each JWT is self-contained, you get scalability without any kind of shared session state. The client itself knows who that person is, has its verification token that it has already gotten signed, and that gives it the access to the information it wants on all of the different services that are using that particular authentication service. So they also support zero trust architectures and API-first designs. So basically, in short, JWTs make it possible to build faster, more scalable, and more secure systems. So I talked about sticky sessions. We did have a customer at a client, a place where I used to work, and they were trying to scale their user system, but they kept having issues with sticky sessions in Kubernetes and keeping everything coordinated, and it was really frustrating. And they moved to JWTs, and they got rid of that particular problem. Obviously, many other problems, but that solved that particular problem. But there's also the flip side. Sometimes people think it's a really great idea to hard code a long-lived JWT into their front-end app. And then someone gets that token, and they have access as long as that token is active. So it's not a perfect system, but it is a really good approach. Come on, system. Oh, maybe if I go on the actual system I'm working on. OK, so what problem are we trying to solve? Well, usually, traditionally, we have taken our session information and we've stored it on the server. When a user logs in, the server creates a session, puts it on the server, and then issues a cookie with a session ID. And then whenever a request comes in, it checks the session ID, and it goes and it gets it out of the session database, which works great for one server. But as soon as you start to need to scale, You can have contention. It can be things can get out of sync. You're replicating session states across nodes. It's brittle. It's stateful, and it doesn't play nicely with microservices. JWTs flip that. Instead of the server tracking the session, the client keeps track of that session. It has a signed token that proves its identity. It's stateless, self-contained, and verifiable. It doesn't need to be looked up in the authentication server to make sure that that user still has access to the resources they're asking for. So to sum that up, JWTs solve the problem of scalable identity. We want to be able to allow the user to access all of the services without having to coordinate information between them. So now let's talk about technical details. There's got to be code on the slide. Sorry that it took me this long to get to the code. I promise usually there's more code, but abstract talks are good too. So the JWT has a header on the left there, and that tells what algorithm is going to be used to sign the signature portion. So it could be HMAC, SHA-256, could be RSA, but the header and the type is always going to be JWT for a JWT. The payload has the claims. I'm going to talk a little bit more about those in a minute. Those are the bits of information about the user that are interesting. And then we want to be passing around. So the user ID is a really great example, but we can actually unintentionally reveal things if we aren't knowledgeable about the JWT restrictions. So one of the things about JWTs, and I'm going to talk about it now, and then I'll mention it again. Most JWTs are not encrypted. They are encoded. Most JWTs people can read. And it's okay as long as you don't say, hey, I have a great idea. We got a user. We need a user ID. How about a social security number? It's not even a good idea to say, this is our first user, so we're going to give them 1. Because then people can guess what other numbers might be. So what do I suggest? A UUID, right? Those things are ugly and horrible, and no one's going to randomly pick the right one. So, but really, serious, I heard someone mention Social Security. I also don't like using an email as the unique identifier because that exposes people's emails, and even now, it is okay for you not to want everyone to know your email address. Okay, so the signature is built by performing a cryptographic operation, taking the header and the payload, which we've encoded with base 64, and then creating a signature using a secret key that the authentication server has, and mashing it all together into that. Isn't that great? That's a JWT. So the red part is the header, the pink part is the payload, and the blue part is the signature. And so it's encoded header dot encoded payload dot encoded signature. This is, when it's base 64 encoded, it's base 64 encoded to be HTTP safe. So, so you can use this token, and you can pass it around in your headers and in your code, and it's not going to break. So I'm going to talk a little bit about claims. So there's a bunch of claims. There are standard claims, and that's what's here. I'll mention them sort of briefly. But there's also, you can have custom claims. You can have your own claims. That's totally fine. The RFC does not restrict or require particular claims, but they do reserve these terms for these particular meanings so that things are consistent. But there's a lot of stuff about the token itself. When was it issued? Who issued it? There's the subject of the JWT, which is probably the user, but it could be a company or some other entity. And the audience is really kind of cool because it can say, this is for finance. So anyone who has finance in their tags, they can see this, right? And then at the bottom, there's JTI, which if you want to be really fussy about replays, like if you want a particular token to work only once, the JTI allows you to say, okay, I'm giving you this token and this other piece of information, give it back to me, and then we'll only do this one time. So for financial transactions and other things of that sort, it's generally very nice to be able to disallow people from accidentally clicking that button 6 or 7 times. Oh, hey, look, it's time to play with toys. All right. So the first thing I'm going to do, first we'll look at the online JWT decoder, which is put together by FusionAuth, which is where I used to work. And it's a really great tool. It is, in fact, where our SEO says everyone comes at FusionAuth. They go to the JWT check. So there's an example JWT here, so that you don't have to type one in, because we're nice people. And so if I click on it, and I'm not, having trouble with my internet, just a second. So, how's everybody's week going? All right, I'm going to use my phone as a tether because sometimes that works. Oh, it looks possible. We have words happening. I'm also going to show you each of these pieces. Let's paste that in there. Okay. So I'll go talk right over here. So up here we have, again, the thing that starts with EY up there. That is the JWT itself. The first section is the header, and that's the part that goes up to CJ9 and dot. The second part is the payload. Payload can be as big as you want. On the other hand, payload can be as big as you want. So you might want to put a lot of data in there, but on the other hand, you might want your application not to get slower. So just like anything else, if you're passing data, you need to make sure that you're paying attention to the resource usage. So here's the header, and let's do a little trick here so that we can see that I'm not making stuff up. Or at least if I'm making stuff up, I'm doing it skillfully. So this is a base 64 decoder. It's just for base 64 decoding. And if I decode the header, I get the header information, right? So there's nothing magic about base 64 encoding. It's ugly, but and it's not super human readable, but it is a thing that we can pass around easily between applications. So in the payload, we have the claims that I talked about. Here, let me make it a little bit bigger. That's pretty small. And if it's small for me, it's small for you. There is one more field here in the payload that I want to talk about just for a sec, which is roles. That's going to be your scopes. You can say finance, you can say customer service, you can say, what marketing, whatever. And they can have read access on the financial stuff, or maybe they're a brand new person in customer service, and so they're able to read the customer service application, but not write to it. So all those things can be in the JWT. And because they're abstract and pointing to things, they're not actually individually identifiable information, which is what we really want to avoid. Okay, so Maybe I should go back to the slideshow. Silly computers, just doing what you tell them. It's terrible. Oh, that is the actual link, by the way, to the JWT decoder, and I totally suggest you go play with it so that you can get an idea of how the pieces work together. Thank you. I will be scurrying now. How is a JWT created? So the user submits their credentials to the server. The server checks the credentials. And if they're cool, they move on and create a set of claims. Remember, we're not putting any personally identifiable information in there. Just enough context to authorize the access you want. The JWT is then assembled in the way that we talked about. And then the server signs the token based on what it says in header. And then the whole token is passed back to the client, and then the client just includes it whenever it makes a request to the API. So one of the things that we saw there was expiration. I didn't talk much about it, but access tokens for your server, you probably want them to be minutes, maybe hours. But you can have a refresh token, and the refresh token can say that as long as everything else is okay, and I give you this refresh token, you just give me another access token. This process is invisible to your user. So you give your user a refresh token that's a year, and an access token that's a minute. And you just, every time they come back, you just give them another access token. They have no idea. But you are keeping your systems clean and pure, because if you didn't like them anymore, you would turn off their access, and the server would no longer give them an access token. So we're going to leave that one because we're running out of time. Okay, so let's just do really quick, cover the pieces that I covered that I think are most important. PII does not belong in the payload. Do not put anything about the user in there. You can put an identifier, that's totally fine, but use something like a UUID that doesn't have any mapping to anything in real world. Use the short expiration times for your access tokens, have long-lived refresh tokens. Don't store your tokens in local storage, HTTP only, or memory. Or you can actually do a front end for back end, where you sort of have a JavaScript section of your code that takes care of that storage part for you. That's all your choice. But you need to validate every token. Just because it was a good token 5 minutes ago doesn't mean it's a good token now. And it doesn't mean that nobody has changed it. So we want to scope it narrowly. We want to only let the people access the things they want, not be lazy with the big permission tokens that everybody can use. And then, well, that's just because you got to have a Spider-Man picture in your thing. So, thank you.